Hello students, welcome to your how-to video for your isotope stability lab assignment. This is going to show you how to use the gizmo in case you're a little bit confused. Now you'll notice I already have the Explore Learning site pulled up and I'm already logged in. I have found the isotope gizmo and I have clicked on that. So here is the page that it would bring you to. You do not need any of these lesson materials down here. You only need the assignment that you find in Blackboard. So what you'll do is go to the thumbnail and click Launch Gizmo, and that'll launch the gizmo for you. When you get to this point, there are a few important things to look at. You do have your element name with the mass number or your isotope notation piece here, and it will tell you whether something is stable or radioactive. And then it tells you how much of the element is found in nature or the abundance. You have the option to have show isotope notation marked, and that would give you the symbol along with your atomic number down here and your mass number up here. And then when you look down here, it has the option to add or take away protons and neutrons. We have nothing to do with electrons this week. That will come at a later date. So we're only focusing on the nucleus with protons and neutrons. And the other important piece to note is this graph right here. The graph itself is going to be what you take screenshots of, and you want to make sure that you're paying attention to the key as well as your axes labels. Now you'll notice the key up here, anytime you have a blue dot, that's going to be a stable isotope of your element. The radioactive dot is going to be green, and then the does not exist dot is gray. So make sure you look at these. And then for your graph, your x-axis or this horizontal line is going to represent the number of protons for your element. And then the y-axis or this vertical line is your number of neutrons. So essentially we're going to find out whether isotopes are stable or not. When you pick an isotope, for example, let's say I'll stick with hydrogen just because it's easier. You'll notice on the graph I have this dot here. It's where the 1 for the number of protons would be. And then it's at the 0 mark for neutrons on the y-axis because I don't have any neutrons. Now I can click Save Point, and that'll save the point on the graph. So that way, when I start adding neutrons, you'll see that this ball moved up, but there still is a blue dot there. So as you move up, you're going to save the point, and then I'm going to keep adding neutrons. And that one was green, and it says radioactive up here. So tritium is radioactive. And you'll notice it now gives you this half-life number. And that's something you're going to want to pay attention to. Now if I keep adding, you'll notice that one's green. Each time you add a neutron, I would click Save Point. And then now I got my does not exist dot, and that's the one that I wanted. So when we're looking at this graph, we have 2 stable isotopes of hydrogen, and the rest are radioactive or unstable isotopes. And now as you go through this, what you're going to do is add to this, both with an element that has 1 greater atomic number and 1 less atomic number. So meaning you have a little bit of a different number of protons. So that's going to be your goal with this. And you're going to look at this line and use it to answer the questions within the lab. We don't have to do anything with the show neutron-proton ratio, so you don't have to worry about that. But again, you're going to end up taking a screenshot of this piece here. If you don't know how to take a screenshot on your computer, there is the option with the gizmo to use this snapshot piece, and that'll take that screenshot of your graph for you. If you have any questions, make sure to let me know. Otherwise, good luck.